Greetings everyone, we are the Group 5 and we are here to discuss experiment number 6, which is all about distillation. In the most general context, distillation means is to purify something, and according to ThoughtCo, distillation is the process of heating a liquid to create a vapor in which that vapor is collected and separated from the original liquid and later cooled. This technique is used to separate components in a mixture or further purify liquids.
The objectives of this experiment is to separate components of a mixture using the two common distillation operations, which are the simple distillation and fractional distillation. Second is to determine the efficiency of simple distillation and fractional distillation. Last is to discuss the results obtained from simple distillation and fractional distillation. The materials we used in this experiment are the following: 2.5 by 150 mm distillation tube, rubber tubing number 4 with 2 holes, 3 ml disposable syringe as receiver, 95% ethanol which is 20 ml, boiling chips, crushed ice or ice water, distilled water, 2 pieces 5 milliliter test tube, fractionating column, alcohol lump, 2 pieces 10 ml graduated cylinder, 2 corks, funnel, 2 universal lamps, 2 iron rings, 2 thermometer, 2 pieces 250 ml beaker, rubber tubing, 10 ml disposable syringe, glass tubing with 4 mm diameter, rubber tubing number 1 with 1 hole.
Simple distillation is a process in which two different liquids with two different boiling points can be separated. It commonly deals with two different liquids that have at least 50 degrees difference in their boiling points. As the liquid is continuously being heated in simple distillation, purified compounds with the lowest boiling point will be the first to boil, hence creating vapor, and will be cooled in the condenser, and using a test tube, we can collect the first purified substance of the mixture. And if we carefully watch the temperature in the distillation flask, we can get a purified substance and we can separate the two liquids properly. And as the distillation progresses, the temperature inside the glass will also increase, and when the temperature reaches the boiling point of the next substance, it will also boil and create vapor, and will also be cooled in the condenser and can also be retrieved using a different test tube, and there we have it. We have separated the two different liquids using simple distillation.
For the simple distillation, first we place a 15 ml alcoholic drink and a piece of boiling chip in the distillation tube. Then we assemble a distillation setup as shown in the figure. Heat the sample using a small flame from an alcohol lamp, and as soon as boiling starts, the vapor can be seen to rise up the tube. Adjust the rate of heating by raising or lowering the alcohol lamp, that it takes several minutes for the vapor to rise to the thermometer. The rate of distillation must be 3 drops per minute. Record the temperature for every 0.1 ml or 2 drops of the distillate collected. Collect the first distillate over the temperature range of 74 to 82 degrees Celsius and set aside for experiment 5. Using another receiver, continue the process until about 0.4 ml remains in the distillation tube. Construct a distillation curve and determine the number of components in the distillate, the respective boiling points of the components, and the approximate volume percentage of the lowest boiling component based on the graph.
Fractional distillation is used when the boiling points of the two substances are much closer to each other. By principle, it is generally the same with simple distillation. As compared to simple distillation, this setup will have added equipment called the fractionating column, which acts as an obstacle to the evaporating substance. In this part of the setup, the gas will condense on the surface area of the glass beads to be reheated and vaporized again until it becomes relatively pure. The rapid rise of temperature indicates that the first substance with the lower boiling point is almost out of the mixture.
The setup for fractional distillation. First, place 15 ml of alcoholic drink and a small piece of boiling chip in the distillation tube. Second, assemble the distillation setup as shown in Figure 2. Third, follow the succeeding procedures in simple distillation. Note, also collect the distillate over temperature range 74 to 84 degrees Celsius. Set aside for experiment number 5. 4. Construct a distillation curve. Plot temperature versus volume of distillate and determine the following based on the graph. A. The number of components in the distillate. B. The respective boiling points of these components. C. The approximate volume percent of the lowest boiling component.
Distillation is the process of separating a mixture into its components. In this experiment, we use two distillation operations, the simple distillation and fractional distillation. Their major difference is that a fractionating column is used for fractional distillation. Repeated distillation or rectification occurs in this fractionating column. So this is the process. The vapor condenses on the surface of the glass beads which are in the fractionating column and then re-evaporated or redistilled, leaving a portion of the less volatile liquid behind so that we can collect a purer liquid. This is the reason why fractional distillations are more efficient in separating close boiling liquids.
The difference between the graph of fractional distillation and simple distillation is that fractional distillation yields a higher slope compared to simple distillation, which has almost a straight line characteristic, which means that there is a continuous rise in temperature, while in the fractional distillation, we have a sudden rise in temperature because when we boiled out the ethanol in the mixture, we only have water left in our original liquid. Also, fractional distillation yields pure distillate because we are continuously boiling and boiling the ethanol, and at the same time, the ethanol condenses once it rises in the fractionating column, resulting into much purer distillate.
Number 3. Calculate the percent ethanol. The percent yield is given by the volume of ethanol over the total volume times 100. Using simple distillation, 1.3 ml of ethanol was gathered after the process, while 4.4 ml was gathered using fractional distillation. It shows that fractional distillation has a higher percent yield of ethanol of 29.33% than 8.67% of simple distillation. However, we cannot conclude solely from these numbers that the fractional distillation is much more effective than simple distillation due to other factors such as the purity of the substance after the process.
Based on our calculations, the percent loss of both the simple distillation, which is 54%, and fractional distillation, which is 44.67%, are significantly high. So we can think of two contributing factors to this. First is the uncollected liquid, which can be the vapor still in the tubes and the uncollected droplets. Another contributing factor is that the liquid left in the distilling flask was not actually measured. So it was merely an assumption that the liquid left in the flask was 0.4 ml.
Number 5. In the separation of ethanol from water using fractional distillation, the distillate always contain about 5% water. Explain. So, due to certain intermolecular interactions, a mixture of ethanol and water forms that boils less than the boiling point of ethanol. Since its boiling point is lower than the boiling points of either single component, in this case which is in water 100 degrees Celsius, in ethanol which is 78.3 degrees Celsius, we can say that the mixture forms a low boiling azeotrope. Azeotrope is a mixture that is characterized by a constant minimum or maximum boiling point which is lower or higher than that of any of the components. Hence, pure 100% ethanol cannot be obtained by distillation of a mixture containing ethanol and water. Number 6. Cite some important applications of steam distillation and vacuum distillation. Steam distillation is used to separate temperature-sensitive organic compounds such as aromatic substances. It is also the preferred method used to isolate essential oils. It is also used for steam stripping in petroleum refineries and to separate commercially important organic compounds such as fatty acids. It is used in desalination processes which creates fresh water from salt water. It extracts oil from natural products derived from organic matter and is also used in perfume and cologne production as well as some cooking materials. While in vacuum distillation, it is a method in which compounds will boil at lower temperature when pressure is reduced. Hence, it is useful to separate components at lower temperature but difficult to maintain lower pressure. It is used in the pharmaceutical industry, chemical industry, and food and oil processing. It is used to purify or separate liquids having a boiling point but thermally unstable. It is also used when the boiling point of the compound or the solvent is too high in order to distill the compound without significant decomposition.
And that is our report about distillation. If you have any questions, just comment below the post and we are going to answer it. Thank you everyone, have a nice day, and keep safe.